Good morning, students. Today we start topic is 2.6.2. See, error in case of a measure quantity raised to a power. Suppose A is equal to Z is equal to A square. Means del Z upon Z is equal to del A upon A plus again del A upon A, means is equal to 2 del A upon A. In general case, Z is equal to A raised to P, B raised to Q upon C raised to R. So here del Z upon Z is equal to power P del A upon A plus power B Q del B upon B plus R del C upon C. Example 2.11. Find the relative error in Z if Z is equal to A raised to 4, B raised to 1 by 3 upon C into D raised to 1 by 2. So here in this case del Z upon Z is equal to A raised to power 4 del A upon A plus 1 by 3 del B upon B plus del C upon C plus 1 by 2 del D upon D. Example 2.12. The period of oscillations of a simple pendulum is T is equal to 2 pi under root L upon G. Measured value of L is 20 centimeter, known to 1 mm accuracy, and time for 100 oscillations of the pendulum is found to be 90 seconds using a wrist watch of 1 second resolution. So here what is the accuracy in the determination of G? Accuracy in determination of the G. So first here we write equation G is equal to 4 pi square L upon T square, means periodic of oscillations capital T. Here we know that small t upon n, or in this case del T upon T is equal to del T upon T, capital and small. Now the equation is del G upon G is equal to 4 pi square is constant value. So del L upon L plus 2 power del T upon T. Okay. Now in the next is equal to, here we know that we have value of the del L, means 0.1 upon L is 20 centimeter plus into del t is 1 upon 90 second. Okay, so final answer is equal to 0.0227 227. Now percentage error. Next is percentage error. Percentage error into 100 means 100 into del G upon G is equal to 100 del L into L plus 2 into 100 del T upon T. Del T upon T. So here final answer is 3%. Example 2.13. Each side of a cube is measured to be 7.203 meter. What are the total surface area and volume of the cube to be appropriate significant figures? In this case, total number of significant values is 4. So first we surface area of the cube is equal to 6, means total 6 number of sides for cube into 7.203 square is equal to answer is 311.299. So round up value is equal to 311.3 meter square. Now next is volume of the cube. Volume of the cube is equal to, here we know that volume of the cube cube is equal to 7.203 raised to cube. So final answer is equal to 373.7 meter cube. Topic is 2.8, dimension of a physical quantities. Here all physical quantities represented in 3 terms. Means the dimension of a physical quantities are power to which the base quantity are raised to the represented quantities. In this case, all physical quantities can be written in the term of M, L and T. First means M means mass. M representing M means mass. Second is length and T means time. So first here we take one example, dimension of volume. Dimension of volume. Dimension of volume, here we know that in this case 3 length for the dimension L into L, so is equal to L cube. Dimension formula for volume is equal to L cube, means L cube. Now next is velocity. Second example is velocity. Velocity is equal to displacement upon time. Velocity is equal to, here we know know that displacement upon time means displacement is one type of length. So here first one, mass, in this case 0, L is displacement 1 means meter per second, here we know that, and T minus 1. Now in next case for acceleration is equal to meter per second square. Meter per second square, unit of acceleration is equal to meter per second square, means displacement upon time square. So dimensional formula of acceleration is mass 0, length L1, and T is minus 2. T is minus 2. Now next example is force. Next example, force. In this case, force is equal to m into a, means mass into acceleration in this case. So dimensional formula, mass is m1, and second one is for acceleration value we complete here, m0 meter per second square, m0 L1 and T minus 2. So force is equal to m1 L1 and T minus 2. Dimensional formula of force is equal to m1 L1 T minus 2, same for energy. Next is dimensional formula for work. Dimensional formula for work is equal to force into displacement means is equal to force F into D. For force, dimensional formula is m1 L1 T minus 2 into L1 for displacement. So is equal to dimensional formula for work m1 L2 T minus 2. Next is momentum. Next example is momentum. Momentum is equal to mass into velocity. Momentum is equal to mass into velocity is equal to mass means m1 and velocity m0 L1 T minus 1. So here m1 L1 T minus 1, dimensional formula for momentum. Next is rho is equal to mass upon volume. Mass upon volume, so is equal to m1 upon L cube means is equal to m1 L raised to minus 3 T0 dimensional formula for